Your next two labs are based on chemical reactions chapter. You will be doing a few reactions and determining the products. Now, what is the physical change? The physical change alters the physical state of a substance without changing its composition. For example, melting and boiling, they are physical changes. Why? Because in melting, let's say ice, solid water, it melts to form the liquid water. But then you started with water, you still have water. Similarly, in boiling, you're starting with the liquid water and you're making vapors, but you're not changing the composition. Again, it is H2O, whether it is solid, liquid, or gas. On the other hand, when we talk about a chemical change, you start with one substance and you convert that to another. So if you're starting with water and you still have water at the end, that is not a chemical change. So chemical reactions are ways to represent the chemical change. They involve breaking of the bonds in the starting materials called reactants. These are my reactants, and forming new bonds in the products. So these CH4 and O2 are reactants that are combining to make CO2 H2O products. We started with CH4 and O2, we ended up with CO2 and H2O. So that's a chemical reaction. The arrow sign means yielding to, so it is producing. Now, so CH4, this G stands for gas, and if you see S written, that is solid. If you see L, liquid, G is gas, and if you see AQ means soluble. The solution, it's a solution, means you may the solution in water. Let's say if I take salt, put it in water, so it's a salt solution. Now, law of conservation of matter is atoms cannot be created or destroyed. You're breaking the bonds in the reactants, you are making new bonds, but then the number of atoms of each type stays the same on both sides. What does that mean? So look at the same reaction here, this one. Methane combines with oxygen gas to form carbon dioxide and water. This is my reactant side. On this side, how many carbons do you see? 1. How many carbons do you see on the product side? 1. So yes, I have same number of carbons on both sides, and that's the way it should be. Is the rearrangement, but you are not creating or destroying anything. How many hydrogens do you see on this side? 4. And on this side you see 2. So what happened to the other 2 hydrogens? So what we do is we put the coefficients to balance the equation. What does coefficient means? The coefficient means the numbers that are written in front of the formula. So here my CH4 was already balanced. My C was already balanced. There were 4 hydrogens here. So to make 4 hydrogens here, I will put 2 on the front. You always put the number on the front, which is known as coefficient. So now 2 times 2 is 4. My hydrogens are balanced. So the next is oxygen. How many oxygens do I see on the left side, reactant side? 2. How many oxygens I see on the product side? There are 2 here And then the number on the front is for all the elements. So there are 2 oxygens in this. 2 plus 2 equals 4. So there are 4 oxygens on the product side, but there are only 4 oxygen. There are only 2 oxygens on the reactant side. So what we're going to do now, this time we're going to put 2 here, because 2 times 2 gives 4. So if you look at the balanced chemical equation, what it means, it's like a recipe. If you're making a cake, do you need the recipe? Or I'm making cake, I need 1 box of cake, I will add 3 spoons of sugar, 1 spoon of baking soda. So we have the recipe, and that is basically a recipe here, which we also call it as stoichiometry, which tells you that 1 equivalent of methane combines with 2 equivalents of oxygen gas to produce 1 equivalent of carbon dioxide and 2 equivalents of water. So because if you are, in order to carry out a reaction in the lab, you must know how much of each reactant you have to take, how to combine them to give the desired product. So if you want to make CO2 by this reaction, you have to mix CH4 and O2 in 1:2 ratio. There are 4 main types of reactions you're going to study in this chapter. The very first one is combination reaction. And as the name says, it is joining of 2 or more reactants to form a single product. So this is the generic reaction. A plus B gives AB. You have 2 reactants and you are making 1 product. For example, now given the statement class, you should be able to write down an equation and then balance it. Because in chapter 3, we learned about how to write down the formulas. Sodium metal. Sodium symbol is Na. Metals are solid. You put S for the solid. Reacts with, add, chlorine gas. Chlorine gas, how does chlorine occur in nature? As in the diatomic form. So there are 7 elements that exist in diatomic form. Hydrogen does not exist as H, it exists as H2 gas. So H2, O2, N2, F2, Cl2, Br2, I2. So anytime if any of these elements, it says, let's say sodium metal reacts with fluorine, then you have to write down F2, because that's the way they occur in nature. To form means to produce, so you put the arrow. To form sodium chloride. Now the formula, how to write down the formula for the sodium chloride, that we learned in chapter 3. We cannot just say there is 1 sodium, 2 chlorine, so write down NaCl2. No. Sodium is combining with chlorine now. Then what will be the formula? Then you have to think, where is sodium in the periodic table? It's in the first A group. First A group, they lose 1 electron and have 1 positive charge. Where is chlorine? 7th A group. 7th A group elements gain 1 electron. They have 1 negative charge. Na plus combines with Cl negative to form NaCl. The formula that you write here has nothing to do with how you are writing the formulas on the left side. Because we are converting our sentence here into the equation. So you have to go back to chapter 3. Once you are done writing the reaction, then you definitely have to check whether it is balanced or not, because unbalanced reaction unbalanced equation has no meaning. It's again like you're making something but you do not have a recipe. So then once you're done writing it, then you balance it. So for balancing, uh, let's look at how many sodium do you see on the left side? 1. How many do you see on the right side? 1. How many chlorine are on the left side? 2. How many on the right side? 1. So that means I have to make this chlorine convert it into 2. So I have to put the coefficient, but the coefficient you always put it on the front. So now I have 2Cl. But that also changed my number of sodiums. So number of sodiums now here are 2. So that means I have to go back and balance sodium again. So put 2 here. So this is going to be my balanced equation. So here, so what does that mean? That means if you want to make sodium chloride, then you have to combine sodium metal and chlorine gas in the ratio of 2:1. And you will make 2 equivalents of sodium chloride. Let's do one more practice question. Magnesium metal means Mg. Metals are solid. Reacts with oxygen gas. Oxygen is also diatomic, so put O2, gas is G. To form means arrow, and forming magnesium oxide. Do not look on the left side to write down the formula for magnesium oxide. Go back to chapter 3. Magnesium oxide is made up of magnesium and oxygen. Magnesium is in second A group, has 2 plus charge. Oxygen 6th A group has 2 negative charge. 2 plus cancels with 2 negative, so it is MgO. And most of the oxides are solids. Next thing, balancing of the equation. Balancing comes after you're done writing the equation. So I have 1 magnesium here, 1 magnesium here, 2 oxygens here, 1 oxygen here. So that means I have to convert this oxygen into 2. So I will put 2 on the front. That makes my magnesium 2 and oxygen 2. So I have to go back and balance my magnesium again so that I can have magnesium, equal magnesium on both sides. So now my balanced equation is 2 equivalents of magnesium combines with 1, no number means 1 equivalent of oxygen to form 2 equivalents of magnesium oxide. Let's discuss a few more things here. I'm going to, let me erase this. All right. Anytime if you see a word combustion, that means we are talking about reaction with oxygen gas. Instead of writing react with oxygen gas, I can also say combustion. Magnesium metal on combustion produces or forms magnesium oxide. So it's going to be the same meaning. So then let's talk about stoichiometry. Stoichiometry basically means relationships. We know what a dozen means. When I say 1 dozen, what it is means basically 12 units. That's all dozen means. 1 dozen of apples, 12 apples. 1 dozen of bananas, 12 bananas. 1 dozen of carbon atoms, 12 carbon atoms. Similarly, when we say mole, that mole basically represents 6.022 times 10 to the 23rd units. It's like dozen means 12, moles means this number, and this number is also known as Avogadro's number. Now, I can say 1 mole basically equals to Avogadro's number of units. So if this word doesn't scare you, then this word mole should not scare you. So going back to the balanced equation, let me write it down one more time so that I have some space here. Give me 1 second. And I'm writing the equation again. It was O2 gives MgO. Solid. So I can also say here, when I said 2 equivalents of magnesium combines with 1 equivalent of oxygen gas to produce 2 equivalents of magnesium oxide. I can also say 2 moles of magnesium combines with 1 mole of oxygen to produce 2 moles of magnesium oxide. I can also say 2 atoms of magnesium combines with 1 molecule of oxygen gas to produce 2 equivalents of magnesium oxide. Now, in the lab, we do not deal with atoms, molecules, or moles. If you want to do this reaction, you want everything in grams so that you can weigh it using the weighing machine and then mix them. So is there any way to convert these moles into the grams? Yes, and that we call it as the molar mass of 1 mole. The atomic mass of magnesium is 12. Did I just say 12? No, it's magnesium, 24. The atomic mass of magnesium is 24. That means we say this 1 atom of magnesium atomic mass is 24 AMU. That's AMU is the unit to measure the mass of an atom. And we cannot do that in the lab. Atom is very small. But if I take 1 mole of magnesium atoms, then 1 mole of magnesium atom will have a mass of 24 grams. And yes, I can weigh 24 grams. And then if I'm saying 1 mole of magnesium, that means how many magnesium atoms I'm talking about, because 1 mole means these many units. That means if I'm saying 1 mole of magnesium, that means I'm talking about 6.022 times 10 to the 23rd atoms of magnesium. But how many magnesium moles I have here? I have 2 moles. So that means 1 mole of magnesium is 24 grams. Then 2 moles will be 2 times 24, which is 48 grams. How many atoms of magnesium I'm talking about? 1 mole is these many atoms, Avogadro's. That means 2 will be 2 times 6.022 times 10 to the 23rd, which will be equal to 1.2 times 10 to the 24th atoms of magnesium. You're going to say where this 24 come from? When I'm multiplying is 2 times 6 12s, then I change it to the scientific notation. So here is 1 mole of oxygen. 1 mole of oxygen gas means how many grams. So oxygen atomic mass is 16. 16 times 2 equals 32. If I'm talking about O2 molecule, the mass will be 32 AMU. If I'm talking about the mass of 1 mole of oxygen molecules, then the mass will be 32 grams. So here this is 32 grams, and 1 mole of oxygen molecules means how many molecules? 6.022 times 10 to the 23rd molecules. The next one is producing 2 moles of magnesium oxide, means 2 times Avogadro's number gives me 1.2044 times 10 to the 24th molecules of magnesium oxide. But how many grams? So look here, I have to find the molar mass for 2 MgO. Magnesium is 24, oxygen is 16. 24 plus 16 is 40 times 2, 80 grams. So 48 grams of magnesium combines with 32 grams of oxygen to produce 80 grams of magnesium oxide. So that means even before you are starting the reaction, you should know how much to mix to get 80 grams of magnesium oxide. In this one, so basically on this slide, you learned a lot of things. And you learned basically that if you are given the moles, you can convert them to grams. That's what we did here. How? By multiplying it with molar mass. This is called molar mass, calculating it like this. If you are given grams and you want to go to moles, you will do opposite. You will divide by the molar mass. If you are given moles and you convert them to atoms or molecules, you use Avogadro's number. So moles, if you are going from moles to atoms or molecules, you multiply by the Avogadro's number, 6.022 times 10 to the 23rd. If you go opposite, you are given atoms or molecules and you're going to moles, you divide by the Avogadro number. And we're going to do a lot more practice on this. If you understood what is on this slide, you will be able to solve at least 5 or 6 questions of your midterm easily. The next type of reaction is the decomposition reaction. In decomposition reaction, you are starting with the single reactant and producing 2 or more products. For example, calcium carbonate. Again, class, at this time I'm expecting that you know the formula of calcium carbonate, because calcium is in the second A group, 2 plus charge. Carbonate is a polyatomic ion, 2 negative. So 2 plus cancels with 2 negative, it gives CaCO3. On heating, you put an arrow, and the way to show heating is that you draw a triangle. Let me draw this triangle again. It's not a really good looking triangle. That's better. Now calcium carbonate on heating produces, and I'm giving you the products here, calcium oxide. Again, calcium oxide is, calcium is 2 plus, oxide from oxygen 2 negative, formula will be CaO, plus carbon dioxide, covalent compound CO2. You first write down the equation. Once you're done writing the reaction, what do? You balance it. So 1 Ca, 1 Ca, 1 carbon, 1 carbon, 3 oxygens. Here is 1, here are 2, 1 plus 2, 3. So the equation is balanced already. Another example, ammonium carbonate. Ammonium carbonate is made up of polyatomic ions ammonium and carbonate. Since we do not have the same charges, remember you're writing the formula, you swap the numbers. So it will be NH4, then this 2 comes here, CO3. Ammonium carbonate gives, on decomposition, you can again put the triangle heating sign. Now this produces ammonia gas. Ammonia gas formula is this. I'm not expecting for you to know this one. If in the exam you need it, I'll give it to you. But yes, you do need to know carbon dioxide. We studied it. Gas. And water vapors. You should know the formula for the water. It is H2O and vapor means gas. Now, students do this reaction in the lab, but unfortunately you will not be able to do it because heating is involved and it releases all the gases, so you have to be in the lab to do it. But let's balance the equation. How many nitrogens are on this side? This 2 outside here is for both nitrogen and hydrogen. There are 2 nitrogens. How many hydrogens are there? 4 times 2, 8. How many carbons? 1, and oxygens 3. Let's see how many nitrogens are on this side, on the product side. Here I have only 1. So to balance the nitrogen, I have to multiply this by 2. That means I have to put 2 here. So now my nitrogen is balanced. Then let's pick another element. Let's pick carbon. I like to balance hydrogen and oxygen at the end. It makes it easier to balance it. There is 1 carbon and there is 1 carbon here. So carbon is balanced. Next, let's take oxygen. There are 3 oxygens on the left side and there are 2 here and 1 here. So oxygen is balanced too. Last, hydrogen, 8. 2 times 3 here, 2 times 3, 6 hydrogens here and 2 hydrogens here. So that makes it balanced. So now my equation is balanced. So what does that mean? That means here, this is my stoichiometry. Stoichiometry means relationship. No number written on the front is 1. You don't write 1, but that's what it means. 1 mole of ammonium carbonate on decomposition produces 2 moles of ammonia, 1 mole of carbon dioxide, and 1 mole of water. So, and 1 mole of ammonium carbonate means how many ammonium carbonates? 6.022 times 10 to the 23rd. 2 moles of ammonia means 2 times Avogadro number of molecules. Avogadro number of molecules, Avogadro number of molecules. That shows the relationship. Give me 1 second. Yes. Alrighty. So here is the stoichiometry.